So we are going to first see about receiver architectures, and then we'll be seeing about transmitter architecture. So in receiver architecture, we are going to see heterodyne receivers. So heterodyne receivers, we'll see how it is functioning. So channel selection filtering is very difficult at higher carrier frequencies. So channel selection filtering, as I said, so depending on every time I get a new channel frequency, I cannot do filtering at that time. It is going to prove difficult for me. So what we are going to do, we are going to perform frequency translation. So translating the desired channel to a lower center frequency so as to permit channel selection frequency with a reasonable Q. So we are going to shift the frequency and ensure that the filtering is performed effectively without disturbing the content of your signal. So that is done by a device called as mixer. So we are going to use the help of mixers in the receiver circuit. So remember, all mixers have two input. One is the input coming from the antenna. Second is the input coming from the LO. So what this mixer will do, it will multiply the two signals. So when multiplication, it will result in sum and difference frequency. So I have omega in and omega LO, right? So this will produce omega in minus omega LO and omega in plus omega LO. And after you filter out the frequencies, you get here. This is one architecture, and see here, that is what, see, this is your RF signal having the bandwidth at minus omega in and omega in. When you mix it with local oscillator, you have all these four types of combination: minus omega in, minus omega LO, minus omega in plus omega LO, omega in minus omega LO, omega in plus omega LO. So all these possible combinations are produced. And when which is the desired so after you have this mixer, you have the low pass frequency circuit, which will take only the low frequency outside and it will reject the high frequency. So the low frequency is essentially going to be this one, omega in minus omega. Negative frequencies we will not consider, it is only for our understanding. And omega n plus omega low is high frequency, it will be filtered out. So this LVF is filtered out only this frequency omega in minus omega low. Remember, mixer is a circuit which multiplies two signal. Multiplying two frequencies is equivalent to producing addition and subtraction of that frequency in frequency domain. Time domain you multiply two signals. In frequency domain, it is equivalent to for generating addition and subtraction of two frequencies. So to lower the center frequency, I am multiplying the signal by local oscillator, and it produce four different frequencies as I shown in the figure. So all the unwanted frequencies are removed. Only one frequency, omega in minus omega LO, is retained by the LPF. See, omega n is RF. RF is a high frequency, and omega LO is a low frequency. So when the frequency gets subtracted, the frequency is decreasing. So it is called as down conversion. So I am mixing by down converting the frequency. The frequency is shifted from high frequency to low frequency. So this process is called as down conversion.